Today we're going to be continuing our lesson on reflections. Go ahead and turn to page 13 where we're going to continue talking about what a reflection is. So let's get started with our first definition. What is a reflection? We've been talking about this definition for a while, so this is not new. What's a reflection? It's a transformation where the pre-image is mirrored over a line of symmetry to create an image. A reflection is a transformation where the pre-image is mirrored over a line of symmetry to create an image. Now I'm going to go ahead and show you the properties of line reflections. There's going to be a lot of work that you're going to be copying here. And if you need to, by the time we get to question 4, or not question 4, property 4, go ahead and pause the video if you need to finish copying these up. One of the first properties of a line reflection is called collinearity. Collinearity. Collinearity means that the points on the same line are still going to be on the same line when I reflect it. So if these 2 points were on the line on one side, when I reflect it, those 2 points will still be on that line. Another property of line reflections is that the distance from the line of symmetry should be the same. So the distance from the line of symmetry is the same. Another property is that you'll have the same line lengths. So if one line is 2 inches long, if you were to reflect it, it will still be 2 inches long. The last property of a line reflection has to do with the angles. The angle measurements will always be the same. So if on one side, 2 lines create an angle that's 30 degrees, if you reflect it, you'll still have an angle that's 30 degrees. So the properties are collinearity, the distance from the line of symmetry, the line lengths, and the angle measurements. Now if you need to, go ahead and pause the video to finish copying down all these definitions before we go on to our examples. So let's get started now with some line reflection examples. So I'm going to scroll this up. All right, the first thing I'd like you to do is to match my graph. So I've went ahead and graphed the points -3, 2, -3, 2, the point 4, -1, 4, -1, and the point 1, 3, 1, 3. Now let's go ahead and name these points. I'll call this first point, point A, then point B, and point C, and lastly point D. That means when we do our reflections, we'll have a new point A prime, B prime, C prime, and D prime. I want you to take a look at our notation here. This little R means reflection, and then beneath there it tells us what the line of symmetry is. So go ahead and use another color pen or a highlighter to highlight what your lines of symmetry will be here, your lines of reflection. So for my first point, they'd like me to reflect over the x-axis, the second point over the y-axis, and the third point, this is new, over y equals x. So my first point, A prime, we said that if a point is reflected over the x-axis, then that means that my points stay the same. So my point will still be -3, 2, but I'm going to need to change the sign of the y value. So if my y value is positive here, in my reflection it'll be negative. That means that my new point, point A prime, will be at the point -3, so -3, -2. More just a little bit. So I'm going to go ahead and call this A prime, and this is my point A. So that makes sense. It looks like that point has been reflected over the x-axis. Okay, now let's take a look at point B. Point B is being reflected over the y-axis. This time, instead of us changing the value of my y value, now we're going to change my x value. So here I have the point its original point is 4, -1. And since it's being reflected over the y-axis, I'll change the sign of my x value. So my 4 is positive here. So over here, my 4 will become negative. Okay, that means that my new point B is at -4, -1. Right there. So here is my point B prime. And here's my point B. So that makes sense. Here's my B, and it's been folded in half, mirrored over here over the y-axis. Okay, the last is y equals x. Now this is a new one. We're going to go ahead and show what this y equals x line of symmetry is. Now y equals x is a line that goes straight diagonally. I did an okay job. Going in the positive direction, cutting your coordinate plane like so. So it's on the diagonal with a positive slope. So when I reflect the point 1, 3, this is my point C, it's going to go diagonally over this line. So instead of jumping straight over the y-axis or straight over the x-axis, it's going to be somewhere here. I mean, I'm going to hypothesize this is where it's going to be. So let's think about what that means. Does this point that I'm drawing right here, does it look like it's the same distance away as point C? Let me actually move my point here. That actually is my C prime point. It's the same distance away from my, my line of symmetry, and it happens to be the point 3, 1. Now if you take a look at what my original point, my pre-image values were, and my image, you can clearly see that the 1 and the 3 and the 3 and the 1 switch places. So when you reflect over the y equals x line of symmetry, you switch the x and y values. Now the last point we're going to take a look at has to do with what a point reflection is. Point reflection means that instead of being reflected about a line, like in this case, everything is reflected about a point. That means it's the same distance away from that point, like it's pulled there. So this is the point D at 2, 5. So I'm going to go over 2 and up 5. So here we go. Over 2, 1, 2, 3, 4, 5. This is my point D. Now the reflection of point 25, I'm going to go ahead and tell you, is -2, -5. You're probably noting, how are these related? My 2 and my 5 are both positive, so if I reflect about the origin using a point reflection, what happens to my x and y values? I write both of their opposites. So where's that point -2, -5? 1, 2, 3, 4, 5, right here is my new point D prime. So as you can kind of see in this case, from the origin, this is 5 up and 2 over, 5 down and 2 over. So it's reflected in the sense that it's the opposite direction. So this is up 5, right 2. So if it's reflected about this, this is down 5, left 2. It's mirroring it in that way. So now comes to our most important part of our notes really today, and that comes down to our rules for line reflections and our rules for point reflection. This is going to be the section that you're going to be probably referring to all day today. So let's start this off. The first thing we want to write down is what's the line of reflection. So if it looks like this, the line of reflection is the x-axis, and below that would be the y-axis, and here y equals x. So here we're just pointing out that these little bottom values that are written here are actually telling me what the line of reflection is. Now the mapping rule looks something like this. This is kind of like your recipe. If you're given the point xy, what do you do if it's reflected about the x-axis? We change the sign of the y value. So that means my mapping would go to x negative y. This is telling me I'm changing the y value. So if I had the point 2, -3, that would map to 2, +3, because my -3, excuse me, would map to the opposite y value of +3. Okay, what about the rule for the y-axis? What would you do there? For the y-axis, if you had the point x, y, what would it map to? Our rule was, if you reflect about the y-axis, you change the sign of the x value. So that means I would have -x, +y. So if I were given the same point of 2, -3, and I change the sign of my x value, it would map to the point -2, -3. Last, what if I was going to map over the line of reflection of y equals x, and I was given the point x, y? What would I do? Well, we talked about this in my example that was right here. We said that if you get y equals x and you're reflecting about that and you had the point 1, 3, what did we do? We switched the components. So that means my y would become my x and my x would become my y. So in the point of 2, -3, if I reflected about y equals x, it would be -3, 2. The last rule I'd like to go over is the rule for point reflection. So what we saw is that if you reflect about the point 0, 0, you would use this mapping rule. So you would take the point x, y, and you would map it so that you wrote the opposite of the x value and the opposite, sorry, that's an x, and the opposite of the y value. So that would mean for my example of 2, -3, that would map to the opposite of the 2, so -2, and the opposite of the -3, or 3. So here's your task now. I'd like you to try to figure out what's the verbal rule for each of these line reflections and point reflections using this bank down here. Which one would you say switches the components, or has the opposite x value, or the opposite sign of the y value, or you change both the signs? Go ahead and go through and see if you can figure out what the verbal rules are, and when you're ready, I'm going to ask you to pause the video right now. So when you're ready, unpause the video, and you can check to see if you got the verbal rules right. Go ahead and pause the video and let's see how you did. Okay, so here's what I wrote. For reflecting about the x-axis, I said that you change the sign of the y value. And for reflecting about the y-axis, I said that you change the opposite sign of the x value. What about for y equals x? Well, that would be where you switch the components. The x becomes the y and the y becomes the x. And last but not least, well, you change both the signs. That's what I would write for my verbal rule there. Great job, guys. So now that we're on the next page, I'd like you to do some practice on your own. I'm going to give you 1 minute. We're going to pause the video and you're going to try questions 1 through 4. You can check in with your neighbors, and when you're ready, unpause the video and let's see how you did. Okay guys, let's see what the answers are. For reflection about the y-axis, number 1, it would be -3, -4. For number 2, reflecting about y equals x, you would switch those to get 6, -5. For number 3, reflecting about the x-axis, you'd change the sign of the y value to get -1, 2. And last but not least, if you're going to reflect about the origin, you're going to get -4, opposite sign, +7, opposite sign. Okay, great job. Now, we're going to take a look at some reflections over the vertical and horizontal lines. Go ahead and put a box around here. It's possible sometimes to reflect about something other than those standard rules that we saw. For example, at x equals 2. X equals 2. X equals 2 is this line right here. Go ahead and take a second and draw x equals 2 into your graph right here. Okay, so if we were to graph this line and then plot this point, -1, 3, so -1, +3, my question now is, how do we reflect about this line? Now, the easiest way for me to do this is to count how far away my point is from my line of reflection. So it is 1, 2, 3 away from the line of reflection. So it's on the left-hand side, so I'll reflect to the right. 1, 2, 3. That means I'm going to take my point and I'm going to drop it right there. Right there. Now let's check it out. Is it exactly 3 away? Yep, 1, 2, 3 away. The location of my new point is at 1, 2, 3, 4, 5 on the x values, 1, 2, 3 on the y values. So 5, 3. So how did I find that? Just by drawing my line of symmetry and then counting the distance from my line of symmetry. Okay, let's try this again. Now, I can clear my board. I know you can't, but I'm going to clear mine for the sake of you being able to see what we're doing. So let me get this out of here. Okay. Okay, now let's go ahead and find the line of symmetry at y equals -3. So y equals -3 is this horizontal line right here. And my point is at 4, 0. So I'm going to take my point and I'm going to drop it at 4, 0, a little bit higher. Okay, and this is the line of symmetry of y equals -3. So let's start counting. If this is going to reflect, it's 3 above this line, so I'm going to move my point, starting at the line of symmetry, to 3 below. Check to see if it's symmetric. That's 3 away and 3 away. This will be the point 1, 2, 3, 4 for the x values. -1, -2, -3, -4, -5, -6. So we said 4, -6. What I hope you're noticing is that in this case, my y value stayed the same, and in this case, my x value stayed the same. Interesting. All right, next question. For our reflecting about x equals -1. So let's clear my board here. So I'm going to go ahead and get rid of this guy. And let's move these points off of my grid. Okay, let's draw the line at x equals -1. That's a vertical line at x equals -1. X equals -1. And let's plot the point -1, or excuse me, 1, -5. 1, 2, 3, 4, 5. Okay, and now I'm going to find where that point goes. So I know it's going to be on the same line right here, and it'll be 1, 2 away. So 1, 2 away, right about there. Okay, so let's find the location of that point. Let's see. Here's 0, so -1, -2, -3, comma 1, 2, 3, 4, 5. -3, -5. All right, let's clear our board. Let me get rid of this part first. Let's clear my board, move all my points over. Okay, my line of reflection for my last problem is y equals 2. So that's going to be a horizontal line at y equals 2. My point is at -3, 1. And my reflection point should be, let's see, 1 away from the line of symmetry, but on that same line. What's the location of that red point? Let's see, -3, 1, 2, 3. -3, 3. So let's kind of summarize what we did here. For these problems where it was a reflection over a vertical or a horizontal line, we really relied on our understanding of what a line of symmetry is and what the relationship is between the point, the pre-image, and the image. We literally counted the distance from the point to the line of symmetry, and then on that same line, counted that same distance away from the line of symmetry to find our new point. Now, here's the test of how you did on your notes. I would like you, right now, to try the classwork and see if you can do these 5 problems in 5 minutes or less. When you're ready, check in with the people at your table and see if you guys have the same pre-images and images. Now, since you're going to have a lot of points on here, I recommend you label your points A, B, C, D, and E, and then find A prime, B prime, C prime, D prime, and E prime, and check them with your neighbors to see how you did. Good luck, guys.